Today we're going to continue down the road of complex numbers. You can see today's lesson is called Complex Numbers Part 2. Yesterday's lesson, I hope you found remarkably easy. It was just adding and subtracting like terms, to be honest with you. And the reason why we kept yesterday's lesson nice and simple is because today's lesson can be a little, if you'll pardon the pun, a little complex. Right? So, yeah, if we did adding and subtracting yesterday, you know what we didn't do? Multiplying and dividing. And that's where we are today. Yes, this is in here. It's in the note packet. So you're not freehanding notes. Let me remind you that the square root of -1 equals I. The numeric value of I is the square root of -1. Now, I is just like any other number. It has to behave by the exact same rules as every other number does. So if I can raise a real number to exponents, I should be able to raise an imaginary number to exponents. But the question is, how do we do it, right? Well, before I do that, let me ask you a question that's not using imaginary numbers. Let's just talk about it like this. The computer's lagging so hard it won't even let me select a pen color. Oh, it has nothing to do with the pen color. It's because it does not see me using the board. Interesting. Well, we're just going to have to pause the video and fix that, aren't we? All right. Screen is calibrated. Let's try again. I was attempting to ask you guys a question that has nothing to do with imaginary numbers. Okay, here's what I was trying to get at. Let's take the square root of 3 and let's multiply it to the square root of 3. What is the square root of 3 times the square root of 3? It'd be square root of 9, right? Yeah, so this is what this does. This does this, square root of 9. But isn't 9 3 squared? You see, anytime you multiply something to itself, like x times x, you get x squared, right? 3 times 3 is 3 squared. So you say, what's the square root of 3 times the square root of 3? You go, well, that's the square root of 3 squared. And what do squares and square roots do to each other? They cancel. So what you're left with is 3, right? So what's the net result? When you square a square root, doesn't it just cancels the radical? The net result is this. Instead of saying the square root of 3 times the square root of 3, I could have said square root of 3 squared, because that's what it means to multiply something to itself, right? It means to square that object. And radicals, the square roots specifically, and powers of 2 are inverse operations. They cancel each other. So you're just left with the value of 3. Okay, now let's take that logic and let's apply it to imaginary numbers. If what's he watching? She's watching him do something. Yeah, just his pen? Oh, okay. Hopefully he's taking notes with that toy. Okay. I squared. In order to figure out what I squared is, you have to remember that I is the square root of -1. So here's what we're actually doing. We're taking the square root of -1 and we're squaring it. But we just saw, using regular old numbers, that when you square a square root, they cancel. And you're left with -1. So as it turns out, I squared is -1, a real number. Before I do any more math, if you have any concerns about this at all, this is the time to address that. Yes, sir. So he wants to know, and I have to just repeat it for the camera. He wants to know why it's -1 and not +1, and let me walk everybody through the logic that he just did in his head. He tried to use this setup right here, correct? You tried to say the square root of negative 1 times the square root of 1, negative 1 is the square root of negative 1 times negative 1, which would be positive 1. And I'm going to be honest with you, that is one of the largest concerns that students have with this material. And the reason why it's not, and I hate to say this, but you see that first way that I showed you to do that? It's actually kind of cheating. It's kind of cheating. That property really only works if the stuff underneath the radical is positive. But because the stuff underneath this radical by definition is not positive, that property that I had on the top doesn't work. Instead, we have to use the one on the bottom. So, and that's why it's negative 1 and not positive 1. But I understand your logic, and I appreciate you thinking like that. Would you know, I've never had a student ask me before why it's not positive 1. They all just believe me. But as it turns out, this property up here only applies to positive numbers. So if it's called the radicand, the thing underneath the radical, if the radicand happens to be a negative value, you can't use that property. You must use this property, this one down here, like that. But wow, good. Wow, I've never had a student ask me before. That was great. I've never had a student ask me, but I have seen forums and stuff on the internet, people talking about it, and that's right, I read math forums. Nerd. So, is everybody cool, though, with I squared being a real number, negative 1? Everybody's calm with that. Remember, I is not negative. I's value is the square root of negative 1. I squared, that is negative. I squared equals negative 1. So for the rest of these, what I'm going to use are just properties of exponents. Can we all agree that I to the third is the same thing as saying I squared times I? Can we agree to that? Well, we just saw that I squared is negative 1. That means that I to the third power is negative I. A negative imaginary number. At this point, a lot of minds get blown. I thought I was already negative. No, I is not negative. I is the square root of negative 1. I is I. Just like any other number, I can be positive or negative. I know it's an uncomfortable thing saying, but what is the value of square root of negative 1? And I go, it's I. I know that's not comforting, but what is the value of pi? You all say 3.14, but does pi equal 3.14? 3.14 is an estimation of pi. Pi goes on forever. So what is the value of pi? It's pi. That's the best way to say it. So if you are comfortable saying something like, what's the value of pi? And you go, it's pi, because that's the best way to say it. Then I need you to be comfortable with understanding that the best way to say the value of the square root of negative 1 is I. It's just a symbol that represents a value that we can't represent any other way. Okay? I to the fourth. Can we all agree that I to the fourth is the same thing as saying I squared times I squared? Comfortable with that idea? Well, I squared is negative 1. So this one says negative 1 times negative 1, which is positive 1. So there you have it. I to the first, I. I to the second, negative 1. I to the third, negative I. I to the fourth, positive 1. It is the student's job to have these memorized. This is something you must memorize. You must memorize these. Oh, goodness. A phone call. All right, so phone call, conversation about crumple versus crumble. Okay, let's get back to the powers of I. I to the first is I. I to the second is -1. I to the third is -I. And I to the fourth is +1. It is up to the students to know these things. The students must memorize these things. Mr. M, what is I to the fifth, I to the sixth, I to the 21st? Exactly. We'll get there in a minute. Was this the bottom of this slide? I feel like there was more here. No, I guess there wasn't. So what is -3i to the third? Well, here's what this is. This is -3 to the third. Oh, thanks, Kevin. I to the third. Because this is a multiplication, I can split this apart into -3 to the third times I to the third. -3 to the third means -3 times -3 times -3. That's 3 negatives. So is my result positive or negative? Negative. And 3 times 3 times 3 is 27. But you are not allowed to leave the answer like this. Your answers, if you remember from yesterday, must always be in standard form. A plus bi. Does the I have an exponent? No. This one does, but not in A plus bi. It cannot have an exponent. If I has an exponent, it is not in standard form. So what you have to do is use the powers of I to make sure that your answer is in standard form. And if we look over to the memorized squiggly bubble thing that I drew, I to the third equals -I. So this says -27 times -I. And when you multiply two negatives, you get a positive. So your value is 27i. And that's in standard form because it does not have a power of I. Now 6i squared means 6i times 6i, but it also means 6 squared I squared because they're multiplied, and you can multiply anything in this world. It works like this. Well, what's 6 squared? 36. And what is I squared? It's -1. So if you say 6i squared, what you end up with is -36. So this is how you raise i's to powers. I will tell you though, I want you to know higher powers of I. I to any power that I ask, you should be able to do. And the reason why is because that pattern that you see, well, that squiggly bubble up there, that sets the pattern of i's. Those are the only 4 values that I powers can have. I, -1, -I, 1. I won. See it? I won. Those are the only values they can have. Of course, you have to know which ones are negative. So it actually does like this. I to the first, second, third, fourth, fifth, sixth, seventh, eighth, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, so on and so forth. And it just keeps cycling through the pattern. So if I ask you to tell me what I to the, come on, computer, catch up with me. I've already cleared the slide. There we go. If I ask you to tell me what is I to the 25th, your job is to say, well, I know it's going, yes? I cubed is -I because it's I squared times I. But what I squared? I squared's value is -1. So I to the third actually says negative 1 times I, which is negative I. Lewis?
Can you go back to the pattern?
Yeah. Mm-hmm.
Whenever the exponent is not even, it's I, and whenever it's even, it's like 1.
Okay, good. Well, it's a real number. So what Lewis has noticed is that anytime the exponent is even, the result is a real number, either positive or negative 1. And anytime the exponent is odd, the result is imaginary, either positive or negative. Yes, that holds true every single time. And there's an even more powerful thing going on here. What is if you had to say one was your favorite up there because it made life easy, which power of I just happens to be the best? I'd say to the fourth, because I to the fourth equals 1. It makes life really easy. You see, every multiple of 4, if you're talking about the exponents of I, equals 1. It makes life really easy. So if I said I to the 25th, the way I would view this as, can I divide 25 by 4? Not without a decimal. But if I did, what is the biggest number, smaller than 25, that I can divide by 24? By 4. Crap, I said the answer. It's 24. You see, 4 goes into 24. And because 24 is a multiple of 4, this equals 1 times I to the first, which is just I. You see, you're looking for multiples of 4 in your exponents because I to the fourth equals 1. So there are 6 I to the fourths right there, but each one of them equals 1. So if I said I to the 57th, okay, well 4 doesn't go into 57. But you know what 4 does go into? It goes into 56. So this is also equal to I. Or if I wanted to get crazy, four doesn't go into 31, but 4 does go into 28. And every time you have a multiple of 4 as an exponent, it just equals 1. So this is how you pull this off. I don't think I've asked you to do that in the homework. I wonder why I would show it to you on the board then. It's crazy, isn't it? I mean, Mr. M wouldn't waste my time, would he? Before I move on, please talk to me. Ask me questions. Please. There's a reason why I separated this from yesterday's material. I highly doubt I have a room full of people that 100% understand what's happening. That means the silence tells me I have a room full of people that probably have no clue what's happening. Maybe you will formulate questions before you leave today. Just out of curiosity, 921s when we get out? Okay. So let's multiply some stuff. You can multiply anything in this world. They don't have to be like terms. So 4i is a number. It's sitting on the outside of parentheses. When you have a number on the outside of parentheses, what do you do in math? Distribute. So you're going to take this 4i and you're going to distribute it to those two places. That's going to give you negative 24i plus 4i squared. Your answers must be in standard form. That means a plus bi, real stuff in the front, imaginary stuff in the back, no powers of I. I have a power of I here. It's I squared. But what does I squared equal? Negative 1. Question for me?
Never mind.
You guys told me I squared is negative 1. So this is negative 24I plus 4 times negative 1. That says negative 24I minus 4. This answer is not correct because it is not in standard form. It's the wrong order. It must say negative 4 minus 24I. Now it's correct. Are you okay with this result? I need to know. You've got to talk to me. Dalen. Because standard form for an imaginary number, or for a complex number, looks like this, where this is the real part and this is the imaginary part. So it should always, if it has both parts, the real part has to be written first. Real means it's a real number, does not have an I next to it. And imaginary means does have an I next to it. Now, for what we're calling number 7 here, I have 2 sets of parentheses next to each other. What operation do we use for 2 parentheses next to each other? It's multiplication, but what's the special word that math teachers use for this? It's an F word. FOIL. FOIL, yeah. So 9 times negative 4, 9 times 7i. So negative 36 plus 63i. Negative 2i times negative 4, that's positive because I'm multiplying 2 negatives, 8i. Negative 2i times 7i, negative 14i squared. First, go Gators, orange and blue. First, we have to combine our like terms. And 63i and 8i are like terms. They can be added. That's going to give me 71i. And what does I squared equal again? Negative 1. So this is actually negative 36 plus 71i plus 14. So we can combine 2 more like terms. The negative 36 and the 14 can be added to give me negative 22, and the real number, meaning no I, must be written on the front. That's finished. You've successfully multiplied 2 complex numbers. The result is a complex number. Okay. Again, if you have any questions at all, you need to ask them. Monday, my plan was to give you an extra credit sheet because I'm assuming you're going to show up with questions, hoping that you're going to show up with questions, or hoping you all master the material. So if you have questions for me, please ask them now. So I'd like you to be able to get all the homework done. That way we can spend Monday just working on extra credit. Nobody's freaking out, so I guess I will continue. So we look here, you go, oh my gosh, oh no, scary. Word of advice. Before you go foiling this thing with 2 objects and this other thing with 3 objects, because oh my gosh, 6 objects, big old powers of I. Before you do anything, you should reduce your powers of I. Simplify your powers of I. So if you have powers of I, the first thing you should do is simplify that. Meaning, right here, I have a power of I. It's I squared. And what does I squared equal? Negative 1. So what we actually have here is I minus 2 times 8 times negative 1. This is 8 times negative 1. So negative 8 minus 2i plus 5. There are some like terms in those parentheses, negative 8 and positive 5. By the way, the first set of parentheses is written out of order. Do you care? Not really a big deal, to be honest with you. So as long as your answers are written in the correct order, no worries. Negative 8 and positive 5 add to negative 3. And now this question is exactly like question number 7. You FOIL, you combine like terms, you reduce your powers of I, you combine like terms one more time. Let's actually use orange and blue this time for funsies. I times negative 3, that's negative 3i. I times negative 2i, that's negative 2i squared. Negative 2 times negative 3 is positive 6. And negative 2 times negative 2i is positive 4i. So your like terms are the negative 3i and the positive 4i. Well, we worked on that yesterday, right? Negative 3 plus 4 is 1. So I have 1i. I have this minus 2i squared plus 6. But I think we've seen it enough times today. I squared is negative 1. So this actually says I must have written too fast. The board couldn't handle it. And then negative 2 times negative 1 plus 6. That's I plus 2 plus 6. You cannot write I plus 8. It has to be 8 plus I, because it has to be in standard form. For time purposes, we're going to skip example number 9, I think it is, to go to the next slide. Don't worry, nothing special happens there. You would FOIL the front two numbers, get it all the way down to a simplified number, and then you FOIL one more time and just wash, rinse, repeat. It's the exact same process. It's just a longer process. This is a quadratic. It's a parabola. It's written in vertex form, right? How many solutions do parabolas normally produce? How many times do they normally cross the x-axis? 2. Okay, well, if you were to have graphed this parabola, it never crosses the x-axis. It looks like this. Its vertex is at 1, 9. Picture not drawn to scale. It looks like that. It never crosses the x-axis. That means its solutions are not real numbers. Its solutions are complex numbers, imaginary numbers. But quadratics normally have 2 answers. What that means is this thing has to have 2 imaginary solutions or 2 complex solutions. Guess what? Imaginary solutions always come in pairs. Always, always, always. So let's solve for x, which is an older skill for us. PIMDOT's in reverse order, SADMEP. Subtract 9 from both sides. Now you can cancel the square with the square root. Canceling a square with a square root creates a plus or minus. And the square root of negative 9 is 3i. And then you just add 1 to both sides. If I were to write these as 2 separate solutions, I'd have x equals 1 minus 3i and x equals 1 plus 3i. Look at those 2 complex numbers. Completely identical except for that symbol in the middle. One's a plus and one's a minus. Well, that plus and that minus created the 2 solutions. These two solutions are called conjugates, complex conjugates. In mathematics, if you have two, they're called binomials because they have two parts. If they're exactly the same in every way except for the symbol that's in between them, if one's a plus and one's a minus, we call these conjugates. And since these are complex numbers, these are called complex conjugates. The only symbol that changes is the one that's in front of the imaginary number. Complex conjugates. And complex solutions will always come in conjugate pairs. Always, always, always. So this one right here says, if 2 minus 3i is a solution, then what do we know? 2 plus 3i is also. That's what we know. They have to come in conjugate pairs. It's impossible to get one complex solution. Again, silence in the room is scary. Tells me you have no idea what's happening. Room remains silent. Okay, well then I'll just go to slide 4, I guess. I mean, why not? No one has questions. So in this slide, I'm just asking, what are the complex conjugates? Well, the complex conjugate of 1/5 I, that's positive, right? Its complex conjugate is negative 1/5 I, because only the sign on the imaginary part changes. Ta-da. Okay. Now this next one doesn't have an I, does it? Yet. See, the first thing you have to do is reduce your radicals. 8 is not a perfect square. What perfect square goes into 8? 2 is not the perfect square, but it's the leftover 4. So what we're going to do is we're going to call this the square root of negative 4 times 2. And what is the square root of negative 4? 2i. The 2 is stuck inside. Before you try to tell me what the complex conjugate is, you write this thing in standard form. This number is not in standard form yet. Now it is. But that's not what I was asking you to do. I was asking you to find me its complex conjugate. So what is the conjugate of negative 5 plus 2i root 2? It's negative 5 minus 2i root 2. The only thing that changes is the sign on the imaginary part. Everything else stayed the same. So the last example. What's the square root of negative 16? 4i. This is not in standard form. Now it is. So what is its conjugate? It's 11 minus 4i. And there you have it. We made it, but barely. I imagine there's going to be some questions on Monday.